Welcome again, everyone, to G Squared Academy, where excellence is epitomized. Before we begin today's video, I just want to share with you my CSEC Chemistry lab notebook. Now, this lab notebook replaces the archaic hardcover notebooks that we have been using for the past 100 years. So this book really is about simplifying things for you, making your life easier, a lighter book to use, giving you less things to write, giving you less things to mark. So it works out for everyone. It works out for the teachers, it works out for the students, it even works out for the parents. So if you are interested in getting this lab notebook, which contains about 35 labs, it covers the CSEC syllabus in every aspect, shape, form, and fashion. If you're interested, you can send me an email. I'm going to put my email address in the link description below. So let me know what's up if you're interested in this book. Thank you. Okay, so the first thing about naming organic compounds is this. The name of an organic compound is its DNA. Wow, DNA. Wow, what do you mean? Now, here's the thing. A name must represent a structure, and a structure must represent a name. Every single organic compound in the world, every single one, has a specific name which is specific to that species. It's not like humans where you have like a million John Browns, you know what I mean, or a million Jane Does. Each organic compound, its name is its DNA. No other organic compound has that name, which therefore means that when you're naming things, you must be careful, you must follow the rules, because you don't want to name something another compound's name, so to speak. Alright, so the next thing now is this. Every single organic compound, no matter how complex the name is, it's really just two names. You have the Christian name and the surname. The interesting thing is this, the Christian name can be very long, just like humans. I mean, your last name is your last name. For example, somebody's last name is Brown, but then their parents decide to name them Valentino, Constantino, Augustine, Julius Caesar, so all of these things until you end up with Brown. So their first name is really just a lot of names, which is the prefix portion, but then their last name is just one said thing. And that is your suffix portion of the name. Now, I've given you an example here. You have 2-chloro-2-butanol. And it might sound like a lot. But here's the thing. The last name or the root name or the class name of this organic compound is butanol. That tells you, the surname tells you the class of organic compound. So we know this is an alcohol because of that. Now, the prefix just tells you all the other things present on this organic compound. See, 2-chloro, which tells you that there is a chlorine group somewhere on the molecule. I'm not going to get into the naming of this species right now, just to show you that each compound has a surname and a Christian name, so to speak. You might hear of 1,1,1-trichloromethane, and you're like, whoa, what's that? But it's the same thing. The 1,1,1-trichloro is just the Christian name, and the methane is the surname. It tells you the group that it belongs to. So think about those things when you're looking at organic compounds. Surname, first name, class of compound, the decorations, so to speak. Alright? So our third point of 6 is this thing. I'm going to show you that there are different types of organic compounds in terms of their structure. Now, organic compounds can either be straight, branched, substituted, or cyclic. I'm not going to get anything different from that. You can get a combination of all of them. You can get a combination of 2, 3, whatever the case might be. But what you're going to find cycles, you're going to find straight things, branched things, or substituted things. Now, here's the situation. How do we know something is straight? Now, I don't know if you'll find this in a textbook or anything like that, but what has always worked for me is this. Alright? I say to myself, you know what? If it's straight, there should be no junctions on it. I should be able to take my pencil and run it from one end of the carbon compound to the other end without having to go back to get to another carbon. Let me show you what I mean. So I'm going to take this red marker, I'm going to start from this point. And remember, these represent carbon atoms. Let me just make them dots for you. Okay? Now, if I take my pencil and I start from this carbon atom and I draw a line there, there, it passes through all the carbon atoms. So I know that this is straight. Well, let's look at the branched example. How do we know this is branched? So, same thing again. I'm going to use the dots again just to show the carbon atoms so you can clearly see them. Alright, I'm going to take my red pen again, marker, sorry, and I'm going to draw a line there. It passes through that one, it passes through that one, and boom, it passes through that one. But for me to get to this one, I would need to go back this way and go down. So it means that I have a junction in this molecule. And that's how I know that it is branched, because it has a junction in the molecule. Alright? So there you have that bit, the difference between straight and branched. Now what do we mean by substituted? Now substitute, if you watch sports, you know what a substitute is. Someone coming on to take the position of another person. Alright, it's the same thing here. Now generally what you find in organic compounds are carbon-hydrogen bonds. Now if you were supposed to replace one of those hydrogens with something else, we call it a substitution. As simple as that. Now, since it's a substitution, it's another element which has substituted the hydrogen. Usually we don't speak about carbon as being a substitute. We'll call it a branch, really, as in this case. But non-carbon, non-hydrogen atoms, we call those things substitutes. So here you have a substitute. We have replaced the hydrogen here with chlorine. So this is a substituted organic compound. It could have been iodine, it could have been oxygen, it could have been something else. But it's chlorine in this case. Alright, so now our final type of organic compound are cyclic compounds. Cyclic compounds. Now I've drawn two for you here because what I want you to recognize is that most organic compounds, because of stability issues, they're either going to be 5-membered rings or 6-membered rings. You may see 8-membered rings and some 7-membered rings, but most often than not, or more often than not, what you're going to see are 5-membered and 6-membered rings. Okay? So these are the different types of organic compounds that you're going to encounter. Now it's important that you know these things because when you're naming, these things become very important. You need to know if you have something straight, if you have something branched, if you have something cyclic, or is it substituted. Alright, so there you have that. Let us move on to the next point, which is number 4. Alright, so this is number 4. Actually, this is numbers. I know you're thinking that it's hashtag, but it's actually numbers in our jurisdiction. Maybe on Twitter you say hashtag or whatever the case might be, but this is numbers. So numbers separated by commas. Very common. Another rule in naming organic compounds. You must separate your numbers by commas. And I've given you an example here. 1,1,1-trichloromethane. Notice that I've separated all the ones by commas. Really. And that's all we mean. Now, you have to be careful because if I were to remove this one, that comma, sorry, it becomes 11, 1, which means something totally different. Alright? And remember what I said first of all, the name is the DNA. So therefore, if this name does not match the structure, then you have a different structure. Okay? So there you have that. On to number 5. Alright, so here's number 5. Another simple one. Numbers and letters separated by hyphen. Now another rule in organic chemistry is that when you have numbers and you have letters, you must separate them by a hyphen. It's as simple as that. And I've shown you an example here where you have 3 being separated from the M by a hyphen, the 2 being separated from the L and the P by hyphens. Now you must have these things because, as I said, without them, the name changes. And if the name changes, then it's a different structure. Alright, so on to our last and final point. Finally, guys, It's our prefixes. Now, there's no way you can name organic compounds without these things. For sure, you can't do that. So, I've given you up to 10, but of course, you can go to higher numbers than that. Right? And these, you must know them, of course, because these generally represent the number of carbon atoms in the longest carbon chain. More about that later. Alright, when we look at naming organic compounds. So these represent the number of carbon atoms in the longest carbon chain. So you have meth, F, prop, but, pent, hex, hep, oct, non, dec. Sounds like we're rapping. You could create a little rap about it for yourself, you know what I mean? So these of course represent 1 carbon atom to 10 carbon atoms, as you can see over there. So there you have it. Hope you have found this helpful, because I know organic can be a little bit touchy.